Have you ever wondered how the principles of electricity work? Welcome to the fascinating world of electrical engineering and physics, where Ohm's law reigns supreme. Named after the brilliant German physicist Georg Simon Ohm, who proposed this principle in the 19th century, Ohm's law illuminates the integral relationship between voltage, current, and resistance in an electrical circuit. It's a cornerstone concept that's as electrifying as it is essential. So, buckle up and get ready to explore the fundamental components of Ohm's law in the next segment. Dive into the intriguing world of voltage, current, and resistance. These three elements are the cornerstones of Ohm's law, a fundamental principle in electrical engineering and physics, named after the 19th century German physicist Georg Simon Ohm. Let's start with voltage, represented by the letter V. Voltage is the potential difference between 2 points in a circuit. It's measured in volts and is often referred to as electric pressure. Simply put, voltage is what pushes electric charges, or electrons, through a conductor. Next, we have current, denoted by I. Current is the flow of electric charges, usually electrons, through a conductor. It's measured in amperes. Current represents the rate at which voltage causes electric charges to move through a circuit. Lastly, we consider resistance, symbolized by R. Resistance is the property of a material or component that opposes the flow of electric current. It's measured in ohms. Materials with high resistance impede the flow of current, while those with low resistance allow current to flow more easily. Ohm's law establishes a fundamental relationship between these three parameters, allowing engineers and scientists to predict and control electrical behavior in various circuits. With these components in mind, we can begin to see how Ohm's law plays an essential role in understanding and analyzing electrical circuits. Now that we understand the components, let's see Ohm's law in action. It's a fundamental principle that predicts voltage, calculates current, and solves for resistance in any electrical circuit. It's all about finding the right balance between these three elements. With Ohm's law, you can predict the voltage drop across a component when you know the current flowing through it and its resistance. You can also calculate the current in a circuit with known applied voltage and total resistance. Similarly, you can solve for the resistance of a component or material when you know the voltage across it and the current flowing through it. Ohm's law is also used to analyze complex circuits, whether they're arranged in series, parallel, or a combination of both. And importantly, understanding Ohm's law is crucial for ensuring safety precautions, preventing component overloading, and avoiding electrical hazards. Whether you're working on a simple circuit or a complex electrical system, Ohm's law is a fundamental tool that enables engineers and technicians to design, analyze, and troubleshoot electrical circuits with accuracy and safety.